Continuing where we left off, we are looking at electron configurations and how to now use the periodic table to actually determine that code of the location of all of your electrons for your element. So the periodic table is really useful because it's broken down into energy levels. Each row on the periodic table represents an energy level. And so if you recall, the first energy level of electrons can hold 2 electrons, and that is shown by the fact that there are only 2 elements in the first energy level row on the periodic table. And they're both labeled as S. Then we move up to the second energy level. The second energy level can hold a total of 8, and here we have the 2 in the S and then the 6 in the P. When we move to the third energy level, it can hold 18. So we have 3s on this row, and we have 3p over here, so that's 10, plus there is also the 3d energy level, which holds 10 more. Sorry. 2 plus 6 is 8 plus these 10, sorry. So that adds up to 18. The only catch is that when we use the periodic table, the d sublevels are off by 1 energy level. So the third row only has 3s and 3p, and 3d actually comes after 4s and before 4p, and that's true for each of the d sublevels. And then when we get to F is actually going to fit in between 6s and 5d, and then 5f is going to fit between 7s and 6d. This is just a chunk of the periodic table that was pulled out so that it wouldn't be in the way. And this is to remind you that this comes right before 5d and 6d. Okay. The sublevels are the S, P, D, and F. On the periodic table, we can label them as blocks, and that's why it says up here the S block, P block, D block, and F block. So when you get to your periodic table, you can just draw a box around it and label it as S. That way you remember all the elements that are in it have their final electrons in the S sublevel. And so let's look at some electron configuration locations of the elements just so that we can see how to use this. So if we wanted to locate an element that was located at 5s1, 5 is the energy level, S is the sublevel, and 1 is how many electrons are in that sublevel. So we have to go to the 5th energy level, which is the 5th row down, 5, and we know that it's in the S, so this is 5s right here. This spot is 5s1 because this has 1 element, 1 electron. This spot is 5s2. So we were looking for 5s1, so the element that we would want would be right here, 5s1. What about 3p4? When we go to the third energy level, because the 3 is talking about the third energy level, we move over to the right to the p block, and then we're trying to find the 4th element because that accounts for the 4 electrons inside of 3p. So 1, 2, 3, 4. It would be this element right here. And if I had a periodic table, which I should, let me grab one real quick. You can just look at the element that is in that spot and you'll know which element it is. So this is actually sulfur, 3p4. I just wasn't thinking about it off the top of my head. Okay, so then if we wanted to find one that was in 3d6, remember the d sublevels are off by 1 energy level. So the 3d, like it says right here, is actually on the 4th row. So we go to the 4th row, and we get to the d sublevel. We want to count over to the 6th element. 1, 2, 3, 4, 5, 6. So it would be right here, and that element would be iron, Fe. Then finally we have 5f8. So we come down to the F block, which is down below, and 5f is the second row of the F block. And we want to get to the 8th element. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like that would be curium on our periodic table. So the ones down in the F block are a little bit more uncommon elements, so we're not as likely to talk about those very often, so it takes me a minute to find those. Okay, moving on. We can actually write out electron configurations. So I have a few different examples. We're going to start with the element boron. Boron is located right here. So it's in the p block on the second energy level, and it's the first element over. So if we wanted to write its location, we would say it's 2p1. So that's its final location. But when we write out the full electron configuration, we don't just say the location of that element, we have to include all the electrons in the whole element. So boron has atomic number 5, so that means it has 5 protons and 5 electrons. It doesn't just have 1 electron, which we've only written 1. We have to include the other 4. The other 4 were in the 2s and the 1s. So I'm going to write 2s2, because there were 2 in the second S sublevel, and then I'm going to write 1s2. So you can work your way backwards, or you could also start from the very beginning, write 1s2, then move to the next row, 2s2, and then move to where boron is, 2p1. You would get exactly the same thing if you worked forwards. Okay, that's that example. So let's look at the next problem. What is the electron configuration of magnesium? If you look at your periodic table, magnesium is located right here. So it is on the 3rd energy level in the S block, and it's the second element over, so that means it has 2 electrons in the S block. So we can write out its electron configuration. So let's try it the other way, where we start from the beginning and we walk across the periodic table until we get to this element and we fill in its electron configuration locations. So we're starting with 1s. So 1s2. After that, we've finished the first row and moved to the second row. 2s2. Oops. 2s2. And then continuing on the second row, we have 2p6 over here. Okay, so now we've used 2, 4, 10 electrons, and we're on to the 3rd energy level. Remember, magnesium was right here, so this is going to be in our 3s2 location. And then we are done because we've made it all the way to where magnesium is located. And so we have a total of 2, 4, 10, 12. And the atomic number of magnesium is 12. So that makes sense. 12 protons, 12 electrons. This is the complete number of electrons for that element. Okay, next question. Which element has this electron configuration? So you could sit here and you could look through all of this, but with this type of question, the most important part is actually the end, because that tells you the location. So 3p5, let's go down to the 3rd energy level, over to p, and this has 5 electrons in the 3p, so we go 1, 2, 3, 4, 5. We get to chlorine. That's the answer to this question. This is the element that has the final electron configuration of 3p5. Last question. Which electron configuration does the atom below have? The wording of that sounds a little strange. I wrote it a few minutes ago, but maybe a better question is, what is the electron configuration of this element? Okay, so what we could do is we could sit here and we could try to write the electron configuration from the Bohr model, but I feel like the periodic table is a little bit easier to use. So let's figure out how many electrons this atom has. It's got 2 on the first energy level. The first energy level is filled. It's got 8 on the second energy level. Second energy level is filled. And then for its valence electrons, it's got 2, 3, 4, 5. So 2 plus 8 plus 5, that gives us 15, which is the same as our number of protons. So this is a neutral atom, and it's got 15 electrons. So what element is atomic number 15? Phosphorus. And that's what it actually says right here, just in case you didn't notice the little tiny writing. This is phosphorus. So phosphorus is located on the 3rd energy level, just like this has 1, 2, 3 rings. 3rd energy level, we come over. These two that are together are for our 3s electrons, and then the other 3 that are separated out are for the 3p. So that means we have 1, 2, 3 electrons in 3p, and this is indeed the location of phosphorus. So if we wanted to write out the electron configuration, we would work our way all the way up to this spot. So we have 1s2 for the very beginning electrons. Those are the ones on the inside of the Bohr model. 2s2, then 2p6. Okay, so that's our entire second ring, our 8 electrons. Then we move up to the third ring. We already said we have 3s2. That's that pair right here, 3s2. And then we're over here, 1, 2, 3 electrons, 3p3. Okay, so you should be able to do this even if you don't have a Bohr model. Maybe the Bohr model helps it to be a little more visual for you. But the periodic table is a really awesome tool for this because everything, if you know how to label the sub-levels and the energy levels, then you should never make mistakes with your electron configuration because you can just count how many are in each section so you remember how many fit into S and how many fit into P. Okay. From here on out, we're going to be practicing electron configurations in class. And hopefully this is helpful for you. But if you have any questions about what you just saw, please write them down and bring them to me. All right.